Hello everyone, my name is Arun and welcome to my channel. This series is user tutorials on C programming, and in this tutorial we'll be looking at the format specifiers and C programming language in detail. And in this video we'll be specifically concentrating about the integer data types. Okay, the format specifiers related to them because they are plenty in number and they are very interesting. Very interesting, and there are plenty of numbers. So this will be in this video. The next video, I think I'll be talking about the format specifications for floats and characters, and let's see how this goes. Now, format specifiers, they serve for two purposes. One, they act as a placeholder so that we can place integers or any data type inside a string to be represented as output in the screen. And two, it helps us to specify and how the data has to be presented itself while being printed out in the screen. Okay, so it acts for two purposes. Now let's look at the data type for format specifications for integers. Now if I have an integer like this, the most fundamental one is actually %i. This %i is actually called as the default format specification. Okay, what it does is that it means it does nothing specific about it. It just prints a number as it is without any kind of a manual intrusion. So that's why it's called as a free specification. It is all default specification. So if I were to compile, build and run this, don't worry about this. These are just warning messages. Okay, I get the number 125 like this. Okay, now if I put a minus sign in front of it, check this out. Nothing specific, the minus sign just comes in front of it. So this is a default one. If suppose I want the number to be presented in a character field of 5 units long. Okay, I just need to put a 5 in front of it. I'll just compile, build and execute and show this out, and you will understand this better. You see, this number minus 125, it occupies 4 characters in the output console, in the output window. Okay, it occupies the length of this number. It takes 4 characters or 4 character width length to represent this number over here. Okay, so that's why 1 for this minus sign and 3 for this number 125. Okay, here when I put %i, what happened is that this number gets shifted to the right by 1 space, and that space is occupied by empty space. Okay, what I am telling here is that when I put a number 5, I tell the compiler that hey, I'm going to print an integer, and for this to print this integer, I need a cushion or a space a space of 5 character lengths long, 5 character units long. Okay, and that's how it comes over here. Place the number in a character field of 5 units long, including sign. Okay, and suppose if I want a number such that I put like 6, okay, this 125 minus 125 can be represented in 6 character lengths. So if I run this, okay, I get a number like this, and there will be two padded spaces in front of it. Okay, and that's how it is. And suppose if I reduce the option, like instead of 125, I put this to represent 125, I need 3 characters length and a 1 negative sign, so I need 4. So instead, if I put 3 something like that, because of the negative sign, it won't be fitting in. But do you think it will throw an error? Just watch. It doesn't. And what happens here is that the number gets printed as it is with the sign. So here's the thing. If suppose you're printing a number such that printing a number of data such that the format specification won't allow it to print properly, okay, then the format specification that we give will be adjusted or modified, or to say that properly, it will be overruled such that the number of data gets printed accordingly. So that correction happens over here because of this %i. So if the format specification we put is inaccurate or not so correct, then it will be overruled by the default format specification for %i. Remember, this addition is actually user made, so if that user made is faulty, it will revert to the inbuilt format specification which is defined for %i. Okay, so something that will make this work fine will be %5i. So this will work fine. Fair enough. And now here's the thing. Instead of this let me run this again. Okay, here if you look at this, there is an empty space over here. What if instead of this I just want the numbers to be padded with zeros in front, then for that I need to put a 0 5 at the a 0 at the front of the number. So if I put 5 over here, it will say that the number is going to occupy 5 characters long. If you put a 0 in front of it, it means that after the number being printed, in front of the number, zeros will be placed so that the number gets padded from the left towards right. So if I compile, build and execute this, okay, minus 125 will be printed as minus 0125, like this. Now this kind of formatting will be very useful in case if you're working with you want to print numbers and they have to be present such that you can compare the decimal the place values properly. Okay, suppose if I don't have this negative sign, let's see what happens. Okay, I'll be padded with one more 0. Okay, that is it. And if you look at it, I just put %i over here, so you get an idea how the number is being printed properly here. Cool. Now one more thing here is I can use %i or %d interchangeably for signed and unsigned data types, but especially for integers. But in general, if you're using unsigned integers, let's say, it's always recommended to use %u, and I'll tell you why. So this is the number unsigned integer minus 100 minus I2. Okay, it's this unsigned integer, but look at the value I put it as minus 123. So technically this is wrong. Okay, now if I compile this, I don't get any warnings pertaining to the value. Okay, but I know it's technically wrong. So if I build this and execute this, look what happens. Instead of minus 123 being printed, okay, at least we would have thought that at least 123 would be printed, but instead of that I get this humongous number and I have no idea how this got. Okay, then this number gets printed because of how the minus sign is being treated inside the the number store inside the allocation. Okay, and all. So this is clearly telling me that something is wrong. Okay, and I am able to get this problem because of %u. Now if I rectify, now instead of %u, let's say if I put %i or %d or something like that, check this out. The number will be printed as it is, and if you look at the console, look at the output, you won't even know whether this number is an unsigned integer or not. You might just think that okay, this is a signed integer, but it's actually an unsigned integer, so this number should not be printed. So if I use %i or %d, if I come across some errors like this, human made errors like this, they will be just bypassed just like that. Okay. On the other hand, if I use %u for these unsigned values, at least I'll be able to get some kind of an indication that there's something wrong, and that's the reason why we should use %u over here. Now if I remove this to minus, both of them will work. %u as well as %i will work, or %d will work accordingly. Now next thing we'll be looking at is the long and short data types. Okay, suppose if you want a data type like long or just long int or something like that, what you do is just put L in front of the format specifier. Similarly, if you come across short data types, you just put an H in front of the data type, and that will do. Okay, and of course u in front of the unsigned, or just u as it is. So the format specification will be like LU for a long unsigned integer, LLU for a long unsigned integer, LLD for a long integer, you can put LLI as well. Okay, and of course there is LI for a long integer, LLI for long integer. I think I am repeating this. Anyway, I think you get the point. And this is for a short unsigned integer, and this is just for a short integer, and again for a short integer. I guess you get this. I suppose you got this and got this well. That will do. And if I want to print the numbers, I can just use them accordingly. I'll uncomment this first. So this will print a long integer. This will print a long unsigned integer. Instead of LD, I can use LI as well. And for this I have to use LU, because if I use LI, if there is any problem, it won't throw up that error. Here I can use HI instead of HT, both of them will work, and this is for short integers. Okay, now if I compile, build and execute this, there we go. Let's see, I2 is 123, gets printed as it is. I3 is 4563, gets printed as it is. Long unsigned int is for 78,532, gets printed as it is. And short int is 78, is get printed as it is. And meanwhile, these specifications that we put, like for 5, specifying how many characters the number should have, or any trailing zeros, padding zeros in front of the number, all these will equally work for all of them, because all of them by default are actually integer. The basic data type is integer, so all these data integers, all of them will have the same features, so these will work for them as well. Okay, final thing we're going to talk about today is that the octal number representation and the hexadecimal representation of the numbers. Okay, these work validly, for unsigned integers or signed integers with only positive values. If they are negative, then this might throw an error or warning. Okay, this will work perfectly for unsigned integers. Okay, so if you have a number like this, and you want the octal representation of this number, the format specifier is %O, and if you want the number to have an hexadecimal representation, you have to put %X. And you want the numbers in such that the hexadecimal representation should have the character variables, the alphabets in them in capitals. You should use %X. So if I compile, build and execute this, there we go. Number 123 is actually equivalent to 173 in hexadecimal representation, and whereas this number 123 is equal to 7b in small hex. This is 173 in octal, 7b in hexadecimal, and 7b with the b in capital if I were to represent the number in capital sense. Okay, and with that being said, that is all I have for you guys in this video. This is about the format specifiers in C programming language, especially for integers. Thank you all for watching, and then now the next video I'll be talking about the format specifications for float and characters. Alright, so see you guys then.